Alright, so today we're going to look at one trig identity. And this trig identity is called the tangent identity. Some books call it the ratio identity. So our learning intention is obviously to understand the knowledge of these identities. And we'll be successful if we can recall this identity and correctly solve problems using this identity. So having our wonderful unit circle, we have cos x and sine of y. If we have this angle as theta, then tan would be opposite over adjacent, and our opposite at the moment would be sine, and our adjacent would be cos. So tan theta is equal to sine theta over cos theta. And similarly, if we have our reciprocal, so the reciprocal is the opposite way around. So the reciprocal of tan is cot. So cot would be adjacent over hypotenuse. So in this case, it would be cos theta over sine theta. And that's the tangent identity. The reason why it's called ratio is because this is from our ratios of SOHCAHTOA. Yep. So, an identity is an equation that shows the equivalence, the equalness of two algebraic expressions for all values for the pronumerals or variables. For example, our famous one that we do is Pythagoras, c squared equals a squared plus b squared. That always works out to be true. Or when we do like algebraic factorization, so a squared minus b squared, the difference of two squares is the same as a plus b multiplied by a minus b. So what we want to do is we want to prove that sine a multiplied by sec a gives us tan a. Okay, so we're going to start with looking at the left-hand side of the equation, so of this equal sign. So the left-hand side is sine a sec a. And what we really want to do is we want to get somewhere to be something that looks like tan. And we know that tan is actually sine over cos. So what we're going to do, somewhere we want to keep a sine somewhere, but we also want to gain a cos. And we know that sec is the reciprocal of cos. Okay, so instead of writing sec alpha a, I can write it as 1 over cos a. Well, if I multiply the tops and the bottoms together, what I do is I get sine a over cos a, and that's exactly what I want, because I want that to be, because that equals tan a, and that actually equals the right hand side. So I have proven that sine a sec a is equal to tan a. Alright, second question. We want to prove that tan theta times cos theta equals sine theta. Okay, so in this situation, I want to get this transferred into something of sine. So the one thing I look at is I think of going, well, tan theta is just sine theta over cos theta. And what I'm going to do is I'm going to multiply that by cos theta over 1. Okay, so that's the left-hand side. Alright, well, this just cancels out with this. And so what's left with is I get sine theta over 1, which is sine theta, which is the right-hand side. Okay. Question 3, we want to prove that cot alpha times sine alpha equals cos alpha. So the left-hand side in this case is cot alpha times sine alpha. Okay. And I want to get to cos. Okay, so I probably most likely want to keep this sine alpha. But what I want to do is change that cot into terms of sine and cos. And that's going to be cos alpha over sine alpha. Yeah, so cot alpha is the same as cos alpha over sine alpha. Same thing again here. This cancels out with that, just leaving us with cos alpha, which is the right-hand side. Okay. Fourth example, we want to prove that cosec theta cos theta times tan theta equals 1. Okay. So cosec is the reciprocal of sine. Okay. So let's still do it. So left-hand side equals cosec theta cos theta tan theta. Okay. Cosec we said was the reciprocal of sine. Cos, let's just keep it as cos. And tan is sine theta over cos theta. Okay. Multiplying all the tops together, we get, I'll put the sines first, sine theta cos theta. Multiplying the bottoms, we get sine theta cos theta. Well, that equals 1, which equals the right hand side as well. Okay, and that's it. Thank you very much.